Section 8.3, Analyzing Geometric Sequences and Series, found in your book on page 425. In our previous section, we were analyzing arithmetic sequences and series, where the common difference was the same. Today, we're going to learn some tools, tricks, and tips for handling geometric series. So our objective is to identify a geometric sequence, which we've already looked at in the past, write rules for geometric sequences, which we've already done that. We're just going to learn some new tricks so we don't always have to kind of guess and check. And find sums of finite geometric series. Again, finite, ones that end. We won't be dealing with the infinite until the next section or two. Okay, first of all, a refresher. Again, a geometric sequence, again, is a ordered list of numbers, okay, in which they have any term, the ratio of any term to the previous term is constant. Okay. So when you divide a term by the term in front of it, you'll get a constant ratio across the whole way. And we call this, again, the constant ratio R. The constant ratio, we normally tend to use the letter R. Just like our common difference, we use D. For a constant ratio, we use R. So to check to see whether a sequence is geometric, we just divide a term by the previous one. We take negative 18 divided by negative 3. Well, that's 6. Take negative 108 divided by negative 18. I don't know that one. And it is 6. So it looks like it's working. So let's take negative 648 divided by negative 108. Yep, looks like we're holding true. Last one. Wait. Negative 388 divided by negative. Oh no. That one did not hold. Oh, I wrote the problem down wrong. That should be negative 3888. I'm like, oh no, it didn't work. There we go, 6. Add an extra 8 on the last one. That should be 3,888. That's way too small. So yes, our common ratio is 6. So yes, it is geometric with an R of 6, a common ratio of 6. Okay, let's check the next one. Let's again take the previous, take 3/4, and divide it by the 1/2. And we get 1.5. So let's take the 5/6 and divide it by 3/4. Not 1/2. So we can tell right there it's not geometric. And there are sequences that are not arithmetic and not geometric. Okay, so there's ones that don't always have a constant difference or a constant ratio. All right, so to be able to write the rule for a geometric sequence, previously we just had to try to find a pattern. We used a negative 1 to the 1 power or something like that, negative 1 to the n power. It was really just a guess and check, which was kind of frustrating. So now we're going to actually have a rule for a geometric sequence. Okay, a geometric sequence. So the rule for the nth term of a geometric sequence with the first term of a sub 1 and a common difference r is given by this right here. A sub n equals the first term times the ratio to the n minus 1 power. So if I have a geometric sequence with the first term of 2 and a common ratio of 3, then I would multiply 2 times a base of 3 to the n minus 1 power. Okay. So to write a rule for the nth term, we need to find the first term and the common ratio. So let's find a rule for the nth term of each of these sequences, then find a sub 10. So first of all, my first term again is right there out front. So my a sub 1 there is 6. We need my common ratio. So to find that, let's divide. 2 divided by 6, which is 1/3. So my common ratio is 1/3. Let's double check that. Let's do another one. Let's take 2/3 and divide it by 2. Again is 1/3. Okay, let's look at r as 1/3. So our rule, our a sub n equals a sub 1 times r to the n minus 1. So my a sub n is going to equal my first term, which is 6, times my r, which is 1/3, and I'm taking the 1/3 to the n minus 1 power. You notice I put a parenthesis around my r, and like they did up here. So you know exactly what part you're taking to that exponent, because the n minus 1 is an exponent. So 6 times 1/3 to the n minus 1. Let's try this. I'm going to type this into my equals. 6 times, parentheses, 1/3 to the x minus 1. I'm going to go to my table and let's type in. My first term is 6. My second term is 2. My third term is 2/3. Yep, fourth term is 2. Okay, so now we need to find our 10th term. So we could have typed in a 10, but look what that gives me. So let's figure this out. So a sub 10 without our calculator, that's going to be 6 times 1/3 to the 10 minus 1. So 6 times 1/3 to the 9th. Let's see, what is 1/3 to the 9th? Okay, it's not handling it. Well, that'd be 1 to the 9th over 3 to the 9th. I believe 3 to the 9th is pretty big. 19,683. Okay, does 6 go into that? Well, here, let's just write right down. So we have 6 times 1 over 19,683. Because 1 to the 9th and 3 to the 9th. So now let's see if I can simplify that. Will that divide by 6? No, not evenly. What will by 3? So I can simplify this. Divides by 3. That goes in there twice. This goes in there 6,161 times. So there is my, and it's 3.0483 times 10 to the negative 4. Really, really small. Let's double check and make sure 3 times 10 to the negative 4. Well, that's approximately. Because again, you see this you're cutting it into a third each time, so it is going to get pretty small pretty fast. Okay, let's do the next one. So first of all, we have a common difference here. Let's find, common ratio. Let's find that common ratio. 20 divided by 10 is 2, 40 divided by 20 is 2. Okay, 2. That one's easier to find. And my first term, my a sub 1 is 10. So a sub n equals a sub 1 times r to the n minus 1. Again, notice how I write down the general form every single time I use it. Please do that on your homework. 10 times the common ratio of 2 to the n minus 1. So 10 times 2 to the n minus 1. So let's find a sub 10. 10 times 2 to the 10 minus 1. So that'd be 10 times 2 to the 9th. 2 to the 9th is pretty darn big. 512, oh, not that big, times 10, 5,120. Okay. All right, well, what if you're not given the first term and the ratio? Okay, let's figure out how to handle something like that. So here we have one term of a geometric sequence is the fifth term, a sub 5 is 32. Our common ratio is 2/3. We want to write a rule for the nth term. Again, our rule is a sub 1 r to the n minus 1. I know my r, that's 2/3. I don't know my a sub 1. But I do know when I put a 5 into this, I get out 32. So let's use that to try to find our a sub 1. Because we know now a sub 5 is equal to a sub 1, my r is 2/3, to the 5 minus 1. And that should give me out a 32. So a sub 1 times 2/3 to the 4th equals 32. So let's say 2 to the 4th is 6. Let's take 2 to the 4th. 16, 3 to the 4th is 81. So this is 16 over 81 times a sub 1 equals 32. Let's multiply both sides by 81 over 16. So now multiply by the reciprocal, that gives me 1. So 32 times 81 over 16. Hey, look at that, 162. There's my first term. So now we can write our rule. A sub n equals my first term, 162, times my ratio, which is 2/3, n minus 1. And there is my rule for the nth term. Okay. Now, what if they don't even give you the ratio? Okay, so let's do one like that. Here they just give us 2 terms. We know our second term is 12. Our fifth term is negative 768. We want to write a rule for the nth term. So we don't even know our ratio. Okay, so again, our general rule is a sub 1 r to the n minus 1. So we know a sub 2 would equal to a sub 1 r to the 2 minus 1, and that should give me 12. So then a sub 1 times r equals 12. Okay, so I know whatever the ratio is in the first term is when I multiply them, I get 12. Hey, now let's do the fifth term. A sub 5 equals a sub 1 r to the 5 minus 1 equals 768. So a sub 1 times r to the fourth equals negative 768. So I have two equations with a sub 1 and r's. Let's put them together. Let's see, let's solve, this one looks easier. Let's solve this one for, let's say, a sub 1, divide both sides by r. So a sub 1 equals 12 over r. Now let's substitute this in over here for a sub 1. 12 over r times r to the fourth equals negative 68. So now when I simplify this, I've got 4 r's on top, 1 on the bottom, so I'd end up with 12 r to the third and negative 768. Divide both sides by 12. 768 divided by 12. 64. R to the third equals 64, negative, excuse me. So then r would equal the cube root of negative 64, which I think is 4. Let's see, 4 to the third. Yep. So my ratio is negative, so r is equal to negative 4. So I found my r. Now I just need to find my a sub 1. Well, my a sub 1 equals 12 over r. 12 divided by negative 4, which is negative 3. So we found a sub 1, we found r. So now a sub n equals a sub 1, which is negative 3, times r, which is negative 4, to the n minus 1. Now I'm going to put that in my y equals to double check these, or we could just type it in. Let's just go to a home screen and type it in. Negative 3 times parentheses negative 4 to the 2 minus 1 should give me 12. Okay, it does. Now let's try 5. So I'm going to bring that back. Now instead of a 2 minus 1, I'm going to go 5 minus 1. And we should get negative 768. Woohoo! We do. It worked. So there we are, our shortcut on finding rules. So there's our rule for our nth term. So now we can find the nth term if we know the first term and the ratio, if we know the ratio and a term, or just if we know two terms and that it's geometric. Okay, now to find a series, the sum. To find the sum of the first n terms of a geometric series. With a common ratio, again a ratio that's not equal to 1. If a common ratio is equal to 1, it's the same number over and over and over again. Hey, we use this rule. So if I'm finding the sum of n of their terms, I take the first term times 1 minus r sub n all over 1 minus r. Again, remember where r is the common ratio and n is the number of terms I'm adding. Okay. So first let's look at here, I'm summing the numbers from 1 to 6. So I'm finding the sum of 6 numbers. So first we need to know what our a sub 1 is, our n and our r. So let's list those. What's my first term? What's my r? And what's my n? My first term, well think of our rule. Our rule is a sub 1 r to the n minus 1. Well, can we just put a 1 into here to see what my first term will be? 1/2 times 5 to the 1. My first term, 1/2 times 5 to the 1. My first term is 2.5. My common ratio, then do we agree my common ratio would be 5? If you're not sure, find the second term. Okay, so our first term was 2.5. Our second term was 12.5, and so forth. So that's our second term. So we could take 12.5 divided by 2.5. Our ratio is 5, like we thought it was, the base right there. Common ratio is 5, and my nth term, my n in this case is 6. My n is 6. because I'm finding a total of 6 terms. So my S sub 6 is going to be equal to A sub 1, which is 2.5, times 1 minus R to the n, 5 to the 6th, all over 1 minus my R, which is 5. Okay. So let's see here. Let's see if we can do this all in. You know what? Let's not do this all in one step. Just, it gets to be too much. 1 minus 5 to the 6th, and let's divide that by, oh, my parentheses in the wrong spot. Let's divide it by 1 minus 5. So we get that, and multiply that by 2.5. 9,765. Okay. So when I add up all 6 of these first terms, and you could do that, you could just list out all 6 of their first terms. We've already got the first term and the second term, we just need 3, 4, 5, and 6, and then add them all up. You will get 9,765. Okay. It may seem quite large, but look at how big this grows. Let's look at what the 6th term is. It's 1/2 times 5 to the 6th. The 6th term is 7,812. So yeah, it gets pretty big pretty fast. All right, so now example 6. This is example 6 in your book. Okay, you can calculate the monthly payment, M, so M is our monthly payment, in dollars for a loan using this formula. So this is a formula, they give you the formula, hey, with a bunch of variables in it, M, L, I, T, I, K. Okay, so let's see what all these variables stand for. L is the loan amount, so L is the loan amount in dollars. I is the monthly interest rate in decimal form. T is the term in months. Calculate the monthly payment on a 5-year loan for $20,000 with an annual interest rate of 6%. So now, to use this, we just need to write down what's L, what's my I, okay, what's my K, and what's my T. So my L, again, L is the loan amount. So what's my loan amount in this case? For $20,000. So there's my loan amount. Okay. I is the monthly interest rate. Again, monthly. So let's look here. Calculate the monthly payment for a 5-year loan with an annual. Okay, they're telling me the annual interest rate is 6%. So that's how much I'll pay per year. So to figure out how much per month, I need to take that and divide it by 12, right? 12 months in a year. So 6% is a decimal, that's 0.06, and then I would need to divide it by 12. So 0.06 divided by 12 to get the monthly into 0.005. That's going to be my I. Again, my K, my K goes from 1 to T, where T is the term in months. We want a 5-year loan. Well, how many months is that? So 5 years times 12 months in a year. I believe that's 60 months. Okay. So now we just need to plug it all in. So M equals L, which is 20,000, all over the summation of K going from 1 to 60 of 1 all over 1 plus 0.005 to the K. Again, if you notice, this is a geometric series, much like this one. First n terms of a geometric series with a common ratio. So my ratio here would be this base, okay? So let's go ahead and let's figure that is 1 plus, okay, so 1 divided by 1 plus 0.005. Okay, it's that big old long thing. That's my R. So let's go ahead and let's store that so I don't have to keep typing that in or rounding. So I'm going to store. Do you remember how to do that? Come down here. Do you see this button right above on STO? So when I hit it, it says answer arrow. That means it's taking the previous answer and storing it at, now I need to pick a letter for it. Well, since it's going to be our R, let's store it as letter R. Which letter R? I would hit alpha, and then letter R is the times button. So I'm going to take that and store that as R. See, then it enters it. So now every single time I type in alpha R, it equals that number. So now I want to do the summation of this. So let's do that. I'm going to pick a different color. So let's figure out this thing over here off to the side. So I want the summation from k equals 1 to 60 of my r to the k power. So to do that, I need the number of terms I'm adding, which is 60. So I'm finding s of 60 equals my first term. Well, let's figure out my first term. So let's see, what is my first term? I would take r to the k to the 1. So my first term is just my r, right? If I take r, alpha, again to get to alpha, we go alpha r to the 1. It's that r, 0.995. So I would be r times 1 minus r to the n, well my n is 60, divided by 1 minus my r. Okay, so now we can just type this in our calculator and we can actually use r. 1 minus alpha r to the 60, because we told our calculator what r is. So there's 1 minus r to the 60 divided by 1 minus alpha, oh, wrong button, alpha r. And that's what I get, and we want to multiply that times r, alpha r. 51.72 blah, 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 blah. Okay, so that is what this is down here. 5172556075. So we want to take our 20,000 and divide it by that. So to prevent rounding error, I'm going to store that again. Store. And I'm going to store that as alpha D for denominator. So there's my D. So now to figure my monthly interest rate, I need to take 20,000, my monthly payment, and divide it by my denominator, alpha D. 300. So my monthly payment is approximately $386.66. And I didn't do any rounding until the very end. So this is the most exact answer as we can get. Since storing gets rid of that rounding error because you're not doing any rounding until the end. Okay. So if I was to borrow $20,000 when interest rate is 6%, for a 5-year loan, kind of like a car payment, buying a $20,000 car. 6%'s actually a little high for a car, but not too bad depending on your credit. For a 5-year loan, 5-year loan's pretty normal for a car, you'd pay $386.66 a month. Okay. Now if you turn over the page, you will see here there are some problems for your turn. I want you to do all of them. 1 and 2. 5 and 6. Again, there are not 12 of them. If you notice, there's a bunch of numbers missing. So do problems 1 and 2, 5 and 6, 9, 10, 11, and 12. Come to class ready to discuss.